Why hello science and cooking, Greg here, and I want to talk about spherification. Now, in the calculations you did about spherification, you assumed that the density of the gel that was created on the skin or the shell of the spheres was equal to the density of water. And this is a fine assumption. But let's say you were a spectacular student and you came up to me, and this may have happened, and you said, I don't know if I believe that the gel has the same density as water. Then I would say to you, okay, well, let's assume that it's not true. And why don't you do an experiment for me and calculate the density of the gel? So this hypothetical amazing student did the following thing. Made a sphere. And the sphere had some shell, some thickness, which we don't know because it was too hard to measure. And then there's some inside. Of course, it's made of water, so we know it's inside. But then you have the skin, which is made up of a gel. And so then we wanted to know, what is the density of gel here? And we know, because we know what the density of water is, which is on the inside, and it's pretty much water on the inside. Let's assume that. Okay, so what do you do? Well, one equation that we can always work from is the equation that the volume of the entire sphere, so, is equal to the volume of the water on the inside plus the volume of the gel. So that's just, this whole thing is equal to the volume of the skin here plus the volume of what's going on inside. Okay. So from this, we need to figure out how we could calculate the density of the gel. Okay, well, we know that the density is defined as the mass of something over the volume of something. And so we can just replace volume of gel with so if we move this equation around a little bit, then we can get volume is equal to mass over density. And so then we can just, so we know we're talking about gel, we can put little gel here, gel here, gel here. And so this is, use this equation, and we know that V gel is equal to M gel over rho gel. So now we have an equation where we have the volume of the sphere, which we can figure out because we can measure, say, its radius, and the volume of the water. That's something we're going to have to figure out, and then we'll be able to solve for the density of the gel. Okay, so what we did here in this experiment was we took the radius of the sphere and measured it, and it was, this radius was R sphere, RS, and so we used the equation for the volume of a sphere for this part, which is just 4/3 pi RS cubed, and we knew what that was. And then the only other part is we need to figure out what the volume of the water is. And so how do we figure that out? Well, what we did was we took the mass also of the original sphere, so we had mass of the sphere, and then we also, when we deflated this thing, and so we deflated the entire thing, and we measured the mass of the deflated, just this, the gel. So then we also had, right, so we had M gel. And of course we did this because I said that we had this over here. Okay. And so then we could again use, we want to use the same equation that we used for the gel, but now for the water we have, this is equal to, using the same equation, we can use it, but now for the water, M water over rho water, density of water, and we know the density of water. It's by definition a gram per milliliter. And so we figured out what the mass of the water was by just subtracting this, so the mass of the sphere, and then we take the mass of the sphere and we subtract the mass of the gel. So here, for M water, we use the fact that MS sphere is equal to M gel plus M water, which implies that the mass of the water is just equal to mass of the sphere, which we measured, minus the mass of the gel. And so now we have all the pieces that we need. We know the volume of the sphere, we know the volume of the water, and then we know everything about the volume of the gel except for the density of the gel. So we did this calculation and figured out what the density of the gel is. And with your data that you have, you can actually do this calculation, and you can see how close you can get to the density of how close the density of the gel is to the density of water. So I hope that was helpful. It might also be helpful on the midterm. And if you have any questions, feel free to, of course, email me. Again, it's Greg, and have a wonderful day.